And we're back. Hello, hackers. I hope everyone is well. Once again, we are going down the list here of modules in the AWS pass. Tyler and I have teamed up and decided to broadcast this content to the community absolutely free because we realize most people don't have access. So you may not be able to get hands-on, but at least you can follow along and see what we see and hopefully learn together with us. So let's dive in. AWS Lambda. Introduction to AWS Lambda. According to AWS, Lambda is a serverless, event-driven compute service that lets you run code for virtually any type of application or back-end service without provisioning or managing servers. While that's a mouthful of marketing jargon, what does it mean? Serverless is a concept that you, as the end user, do not need to build or deploy any infrastructure to run a Lambda function. AWS manages all of that for you. AWS claims you can simply write and upload code as a zip file. In reality, each Lambda is a function that runs in its own container with multiple isolation layers between AWS customers. But all of that is abstracted away from the customer by AWS. Lambda supports a number of languages called runtime environments. The most popular are Node.js, Python, Java, and Go. Event-driven is what happens after you upload your code. All Lambda functions are triggered by an event. That event can be a manual invocation of the function or tied to other activities in the account, such as a console login or a user writing an object to an S bucket. This event-driven nature allows you to create complex applications based on multiple AWS services. Because Lambda functions are event-driven, they have a few limitations. The most significant limitation is that a Lambda function can run for no longer than 15 minutes before it times out. AWS Lambda is one of the next frontiers of cloud-native applications, so it's important to know how they work, how to create them securely, and how they can be attacked. Additionally, many cloud security tools leverage Lambda to manage security events, so as a cloud security practitioner, you'll need to be able to build the Lambda. Learning objectives. Understand the benefits and limitations of AWS, Lambda service, and Lambda functions. Learn about the various components and settings for a Lambda function. Understand the multiple ways a developer or operator can misconfigure a Lambda function to make it less secure. Ready to get started? This second part is we're good. It's just if you have any troubleshooting issues with the room, I think we're solid. AWS instantiates a new execution environment when a Lambda function is first invoked. This instantiation is called a cold start and is significant for applications where response time is critical. If multiple requests come in at once, AWS will scale up the number of execution environments. Only one invocation will run in an execution environment at any one time. However, after the invocation is completed, the execution environment will be reused for subsequent requests for a non-deterministic period, but typically between 45 minutes to an hour. After the Lambda execution is instantiated, the function handler is invoked. This is where the Lambda service calls a specific function or method in the Lambda code. The inputs of the invocations are called the event. Also passed to the handler is the context, which contains details such as the Lambda function name, login information, the function timeout, and time remaining before the timeout occurs. Here's a basic Python function that simply prints out the environment variables inside the Lambda execution environment. And as we can see, this is Python. We're importing some libraries. And there's a logger getting loaded here. Okay, so the code outside the Lambda handler is executed when Lambda creates the execution environment. In this case, it's setting up the default Python logger module. Each time the Lambda function is invoked, the function named Lambda handler is called, with the event provided by the caller and the context defined by the AWS Lambda service. This function then logs the event in each of the environment variables. When a Lambda function execution completes, the object returned is passed back to the caller. Lambda functions can be invoked synchronously or asynchronously, and in a synchronous invocation, the caller waits for the function to finish while executing before returning. With an asynchronous invocation, the caller sends the event but doesn't wait for the execution to complete. It's incumbent on the application designer to handle error conditions and the resultant output for these fire and forget invocations. You can develop Lambda functions in the Lambda console, or via infrastructures as code like CloudFormation or Terraform. When you're developing in the console, you can create test events for your functions. So this kind of just gives us a screenshot of what that looks like in the console. Pretty simple event. You can have multiple test events and give them unique names. You can even share the test events with other developers in the same AWS accounts. Answer the questions below. Go to the AWS Lambda page, okay, in your account, name TryHackMe Lambda Room Sample function and generate a Hello World test event and invoke the Lambda. See what information to return and what is the value of the context key memory limit in, I guess that's megabyte. Okay, so if we go here, go to that sample function, and we'll test it. Okay, go to details. Okay, I see megabytes here. Memory limit in megabytes. Okay. 128, right? Okay. Now save the value of invoked function ARN. You'll need that in a future task. So let's go find that value, invoked function ARN. Okay, that must be this guy. Okay. So we need to hang on to that guy. Okay, so I'm just going to save him right here as a quick and dirty way to save. Okay, components of Lambda. AWS Lambda functions have many moving parts, and it's good to know what most of them are when defending, attacking, or just building with Lambda. You can find most of these settings and components in the Lambda console, and we've created a sample function for you to play with. Code. Lambda code is typically stored as a zip file in S3, but for smaller functions, you can often pass the zip file as part of the API call. Every code package must have a file name specified by the handler, and in that file, a function or method specified by the handler. The exact specifications for the handler are runtime dependent. Test events. You can configure test events for writing and troubleshooting code in the AWS console. Memory and timeout. You can specify the amount of memory allocated to a function, 128 megabyte to 10 gigabyte. The Lambda service allocates CPU capacity to the execution environment based on the memory size. Additionally, you can specify the amount of a function. You can specify the timeout of a function up to 900 seconds, which is 15 minutes. AWS Lambda billing uses two dimensions, the number of executions and the gigabyte seconds of execution. A Lambda function that uses 3 gigabytes of RAM and runs for 3 seconds bills at 9 gigabyte seconds, right? 3 times 3, I guess. A 512 megabyte function that runs for 4 seconds will bill at 2 gigabyte seconds. Runtimes. Every Lambda function has a selected runtime. Node.js and Python are the most popular runtimes, but Java, Ruby, .NET, and Go are also available. Customers can even create custom runtimes. You can find the complete list of runtimes at AWS's website. Role. The execution role is like an IAM instance profile. It's a set of predefined permissions. The function has permission to act on resources in the AWS account. In AWS's least privileged fashion, you must explicitly define the ability to write logs to CloudWatch logs in the Lambda execution role. Environment variables. AWS Lambda allows configuring environment variables as part of the Lambda runtime. This allows developers to use the same code zip file across multiple environments, dev, test, prod. The same Lambda :get function API call that gets the code will also grant you a copy of the environment variables and values. Because environment variables could contain sensitive information, AWS encrypts them using Key Management Services, KMS. Invocation policy. In addition to the execution role, a Lambda function can have a resource-based policy that defines who or what can call the Lambda :invoke function call on the function. When we discussed resource policies in the IAM module, you invoked a function in the AWS account, that account number. That was possible because the TryHackMe timed function granted invoke function to all of the accounts in the TryHackMe organization. It is possible to have a public Lambda function that anyone could execute if they knew the account ID, region, and function name, the unique components of the ARN. Logging. The Lambda service will log any data written by the function to standard out, which is just output to screen, or standard error messages, to CloudWatch logs. CloudWatch logs is AWS's monitoring and observability service and consists of a service that can accept metrics and logs. CloudWatch also allows you to create alarms and dashboards about the metrics and logs. Each function will write its logs to a log group called AWS Lambda, and then your function name. You cannot change the name of the log group, nor can you configure multiple Lambda functions to write to the same log group. VPC, Virtual Private Cloud. By default, AWS Lambda functions are assigned a public IP address from a dedicated pool of AWS-owned IP addresses. However, it is possible to have a function invoked inside your VPC with a private IP, RFC 1918 address. This is typically required if the Lambda function must communicate with internal resources like an RDS database or a resource in an on-prem data center. When a function is created inside a virtual private cloud, a hyperplane ENI is created in each specified subnet that all Lambda execution environments share. Like all ENIs, these Lambda ENIs have security groups attached to them. While Lambda execution environments usually don't listen for incoming connections, you can use the egress or outbound rules of the security group to determine what resources the Lambda function can access. Concurrency and throttling. Since Lambda functions are event-driven, an extremely large number of events can potentially trigger a large number of executions. In order to capacity plan and avoid runaway Lambda bills, AWS implements concurrency limits on function executions. An AWS account will support 1,000 simultaneous Lambda executions in each region by default. If your application needs to scale beyond 1,000 concurrent connections, you can request a limit increase with AWS support. When the concurrency limit is reached, executions are throttled. Events are not lost, but instead queued up for later execution. Lambda developers can also set a throttling limit on a per-function basis to not exceed the scaling capacity of resources the function relies on. EFS. Every Lambda execution environment has 500 megabytes of scratch space in the temp directory. That is the only part of the execution environment file system that is writable by the function code. When the execution environment is terminated, the contents of temp are lost. For most use cases, that is fine. Lambda functions are intended to be stateless. A recent addition to Lambda is the ability to mount an elastic file system into the function. Amazon Elastic File System, EFS, is AWS's Managed Network File System, NFS, service. It allows EC2 instances, containers, and Lambda functions to share a common file system. Lambda layers. Often a developer needs to share a common set of code or libraries across a number of Lambda functions. Rather than embedding the same set of code and libraries in multiple zip files across potentially hundreds or thousands of functions, AWS Lambda has the concept of a Lambda layer. The layer is expanded and is available to the runtime when the execution environment is created. Lambda layers have resource policies so that they can be shared across accounts. Files in the Lambda layer will appear in the Lambda file system under the op directory. Lambda function URLs. AWS recently introduced Lambda function URLs. These are dedicated HTTPS endpoints to your function, allowing it to be invoked over the internet. The URLs are in the form of HTTPS, the URL ID, .lambda URL or TAC URL, and then the region .on.aws, where the URL ID is unique identifier. AWS states, Lambda generates the URL ID portion of the endpoint based on a number of factors, including your AWS account ID. Because this process is deterministic, it may be possible for anyone to retrieve your account ID from the URL ID. Function URLs can be invoked with or without IAM authentication. If IAM authentication is required, you must sign the request as part of the HTTP request. If no IAM authentication is required, any simple curl command from anywhere will invoke the function. Answer the questions below. Using the AWS CLI, investigate this Lambda function in another account. Okay, so that is not our account number, obviously. So if we do it from our account, which will attach profile, this is my profile for my account for this room. Let's see what we get back. Wow, we get a lot of output. This must be that big URL they're talking about. And okay, what do we got here? What is the runtime of the function? Okay, runtime is Python 3.7. Okay, so definitely using run Python. What error message did you receive when the get function command, that's our get function command, tried to read the environment variables? So we're looking for an error message. Okay, we got error code, access denied exception, and here's the message. And it's this big, long message. Lambda was unable to decrypt your environment variables because the KMS access was denied. Please check your KMS permissions. KMS exception, access denied, exception, KMS message. The ciphertext refers to a customer master key that does not exist in this region, or you're not allowed to access. So if they want, let's see, I believe they want this entire thing here. Fingers crossed. Okay. Okay, using curl, download the zip file referenced by the code location. Open the file and enter the contents of question3.txt file. So we see that there is a zip package, and then this must be what it's pointing to in this S3 bucket. So this must be that feature they were talking. Oh, we did that. Okay, let's select quotation to quotation. And we'll do a curl, holy moly, and then we'll output it to lambda.txt, or sorry, it's a zip file. Okay, we'll unzip it, lambda, and okay, so we got a question 3 and a lambda. Okay, how many people are curious about the picture? All I hear all day long is how great Lambda is at this, or how wonderful Lambda did that. Lambda. Okay. Interesting. And then question 3.text. Of all the Lambda functions in all the accounts in all the regions, you had to download mine. So apparently, a little tongue-in-cheek here. He's not too happy that we found his or hers. So that's the contents of the question 3.text. Okay, handler functions missing from the zip file. What should the file name be? I mean, shouldn't it be question.text? What does the hint say? Recall that the handler file is defined by the handler attribute of the function's configuration and the runtime. Okay, I'm not sure what any of that means. We know we're using Python, and they're labeling it function here. Oh, and then we got handler. Function dot lambda handler. So what are they looking for here? It's function, and then the runtime would be Python. Okay, still don't understand the question, but obviously that's what they were after. And then Lambda misconfigurations and attack vectors. There are several ways Lambda can be misconfigured or attacked. The primary risk is via insecure code. Most Lambda functions execute based on an event that is user-generated. If the code doesn't validate user-supplied inputs properly, a Lambda function could be compromised. An additional risk is when the code writes sensitive data to standard out. This data would appear in the CloudWatch logs for the function to be visible to anyone with read access to the account. Another way that Lambda functions can be misconfigured is through overly permissive execution rules. Granting a function more permissions than required increases the blast radius of the damage that an attacker can do with any code vulnerability discovered. Role permissions are available via the environment variables AWS _access _key ID, AWS secret access key, and AWS session token. If you remember, those are the ones that we put in the config file with the .aws, and of course, if we're looking for an assume role or we get a temporary role, that we also have the session token that expires, I believe, in 60 minutes. I think is the default. If the code allowed an external attacker to access these three environment variables, they would be able to use the powers of the function to engage in potential privilege escalation or data exfiltration. While user-defined environment variables are KMS encrypted, they're typically easy to access from within the function or via the API or AWS console. If environment variables are used to pass secrets to the function, those secrets are easy to exfiltrate from the account. How the Lambda function is invoked can be a security misconfiguration if the resource policy is misconfigured. While resource policies are usually used with the Lambda invoke function, IAM action, if you use Lambda with the wildcard asterisk, instead, the principal would have the ability to upload new code. If the resource policy allowed all AWS users, that is principal asterisk, then you would have a major security risk. It's important to realize how Lambda concurrency works as an attacker and defender. As an attacker, you can use Lambda concurrency limits to engage in denial of service attacks and potentially throttle Lambda functions used to respond to security events. As a defender or author of a function responding to the security events, understanding throttling and implementing some reserved concurrency can mitigate the potential damage from a Lambda denial of service event. Modifying a Lambda layer is a great way to inject malicious code into a large number of functions. Note to self, go after the Lambda layer. Finally, when you call the Lambda get function API, part of the response is a pre-signed URL to download the code zip file from the Lambda services S3 bucket. This is a useful discovery tactic because developers often hard-code things in their applications where they shouldn't. In the next room, you'll get a chance to use many of these techniques to exfiltrate sensitive data using misconfigured Lambda functions. Answer the question below. Using the command AWS Lambda get policy, get query, output tax, function name, and then function arn from task 3, which I believe is our guy up here. Retrieve the invocation policy for this sample function. What is the action for the most permissive statement? So, okay, we're going to copy pasta this and let's grab what they asked us to hang on to. And then we got to just add our profile for the room. TryHackMe 2. And what do we got here? Okay, neat little trick. When things are a little jumble here, we can use this little thing called JQ. Little utility. If you're on a Mac, it's brew install JQ, and you can pip3 install it or pip install it JQ. And it just makes it look a lot better, right? A lot easier to read. So it is asking us, what is the action for the most permissive statement? Okay, so we've only got 2 statements. Here's 2 actions. Which one would be more permissive? Well, you could flip a coin here, but if we look at it, we have an invoke function, right, which is like calling or running, executing. And then we have Lambda update function code. Update function code. So, audience, what do you think? What's more permissive? What could you do more damage with? Just executing or running something, or actually editing the code, updating it? Well, I'm banking on update code. Like that seems to be, you could do just about anything there. So let's see how we did here. Okay. In your account, there's a function named TryHackMe Lambda Room envars function. Invoke this function via the console. What is the secret? What is the value of secret connection string? Okay, so we want to get to the console. Functions. Here's our function, envars. And I guess we'll have to test it. Okay, ran, got output, lots of output. And it's asking us for what exactly? Oh, the secret connection string. Okay. Did anyone see that? Ah, secret connection string. I guess that's this guy. Which, look at that. Joshua, Whopper. I'm getting a War Games flashback here. Anyone else? Okay. What file is deployed by the Lambda layer? Okay, I think I saw that. Lambda layer file, flag.txt. Okay. Okay, maybe I should go back to typing school. And then modify the TryHackMe Lambda Room envar function to echo the contents of the flag. Okay, so we got to modify some code. So let's go to code. Okay, let's look at this code. Okay, it's Python, obviously. We're on time 3.7. And os.system ls opt. Now remember, we have that flag.txt, right? So that's the file that's attached to this room. And if I recall, it said something about everything goes into the opt folder, right? That's where things are happening. I remember reading that. You guys remember that? Opt folder. Anyway, trust me, I do remember that. So flag.txt, pretty CTF-y here. That's our target file, and we want to cat it, right? I mean, that's what I would do. So how about we add another line? We do another system call since we're in Python here. And then we literally just do what we would do in Bash from the command line. So we would do the absolute path, opt, and then flag.txt. Okay, that should output it to standard out. Okay, check him out. Syntax here. Deploy. Okay, updating the function, successfully updated. And then if we test, okay, this is our output. Ooh, look at that. So that's what it did. And I guess the contents of flag.txt is the only move is not to play. Again, reference, you remember that famous line from War Games. Yay! And that is a wrap, everyone. So hope you got a little bit better understanding of AWS Lambda functions. Pretty neat. Until next time, happy hacking.